How's it going, everyone? Eulier. Again, looking at the enterprise we're developing is specifically the architecture for testability. And this is a very interesting topic and something that a lot of people actually now come up. And this is a high level discussion. And by high level, I mean is that now instead of thinking of how you're going to organize this, all of these user elements in your applications to, let's say, build an e-commerce or some sort of landing page or that kind of stuff, is now understand that how can we now write our components in a way that is testable, in a way that is maintainable, enterprise UI development, right? So because of that, we went over to describe is what maintainability is, and I think this is very, very important to describe because this is where all of this problem comes here. So this is a course taught by Steve Kinney, head front-end engineer at Temple, and by understanding that now, what are the things that we need to maintain our code over a huge range of contributors distributed in large teams, how can we make that code base maintainable over a long period of time? And this is something that is not rely exclusively on one single architecture, but it is more on an adapted architecture. So perhaps at the beginning of your application, this is how you should set up things. And that's what we have, for example, like Next.js, where they tell us, hey, you know what? We're not opinionated. So we are unopinionated about how you organize and collocate your project files, all right? Which is a good thing because they don't mess in that area. However, it is important for us to understand that when we need to actually provide or have a way of doing stuff, is understanding what is the end goal of this. So we have is several, not only folder structure, but also is architectures that allow us to deal with this kind of complexity. The complexity of maintaining on applications. And that is, we went through describe is, for example, the spectrum, or what are the basic installation needed to lay out the foundation here, that we need to have some sort of systems that works towards that goal, which is the testing, the build, and the static analysis. And then on top of that, all right, you're going to now is define some sort of process, such as, hey, how do we make sure that we integrate our code, and the code that we integrate is something that is quite good, all right? So code reviews, design documents, or blueprints, and then on top of that, this is just process, okay? And as you do this process, this is stuff, there are recurrent problems that come up here. And one of them is the architecture. You know, it's like, good, now that we're integrating all of this code, how can we make sure that we maintain our code in a way that is maintainable, right? So what is the architecture? So what is the basic installations needed to make that happen? And that is now also is not only, again, this is all for UI, okay? So not only is what is the architecture that we need to define for building our user applications, for web applications, all right? And also is some of these other patterns. So for example, hey, how can we now manage states in our applications? How can we now handle abstractions to make our code much better, or to make our code much more testable? Abstraction for testability, state management, to understand how can we deal with that, and the other is the folder structure or the architecture. So, because so far we went to describe as the systems like that, and here is look at the spectrum of testing, and also how we can implement or build process. We didn't dive deep too much into the static analysis, which is something that we should do, but just to recap, one of the systems that we need to put in place to guarantee is this pyramid of needs, the Maslow pyramid of needs to maintain our code. Well, one of them is the system, the build process, and the static analysis. And we look at the system, we zoom in and say, hey, this is now in a spectrum. You have unit testing, you have end-to-end, you have in the middle something like the component testing and the integration testing. And where now unit testing is much cheaper than E2E, it solely focuses on one thing, and that is that this function works as expected. For that, we use now a library called Jest, that allows to run this assertion and also some of the logic there and some of the jargon as well, like test suites and assertions. At the end of the day, we are testing is just JavaScript functions, and that actually give us what we need to give us what we expect to get, right? So this is when we dive deep into the concept of JavaScript and how JavaScript now treats their functions and objects and values, and how that it is stored in there, which is a great thing. And now how Jest actually expose some of these common methods so we can verify that a function do what it's supposed to do, right? So to be close to be equal, and how now they check is referential equality and value equality, and the other methods like to match objects to contains, the check if an element is on the collections, to undefined, to be instance of, to throw errors, to expect .any, expect object contains, or array that contains. How can we now set up our tests in a way that is much more meaningful for us? So develop this discipline for testing, such as, hey, define all of the setup thing, or put up the setup first, and then your testing logic, and lastly your assertion. And how by creating all of this small chunk of tests, so the valuable position of tests is that you now continuously so you are continually have a guarantee that things won't break behind your back. That's the value proposition of tests. Now, we also went how can we handle this on asynchronous nature of our JavaScript here, especially when handling is this stuff. And the stuff, I mean, that is the asynchronous nature of the language. So with async and await, or expect.any and reject, and all that kind of stuff. And how can we start to use this async and await? For example, is for timers, or for things that show in the UI and then disappear after an X amount of time, right? And then, because this is now the testing, unit testing part of the spectrum, then we move on to the another aspect here, which is the build system, okay? And now the build system is the way of how we define is this CI/CD process, which is using is Git as a way to say, hey, you know what? It'll be great for us if we have some sort of way, mechanism, automated process that we can integrate code and then deploy that, right? So this is when now the computer science kicks in at the end of the day, and that is the study of informations, computation, and automation. And I think this is something that is missing a lot of the time, especially for those who are working in this area, right? We are now writing our own extinction. No, not like that. But we are now is writing our own things that we don't want to deal with. That's what happened. We are defining all of this system. We are writing all of these systems that we delegate to this computer, okay? So we don't have to handle that for us. And I think this is something that a lot of people that actually when they're writing this code, especially because there is a human component that is, hey, I don't want to be replaced. I don't want to be that and this and that and that. No one does. Understand that the only thing that you're replacing is the stuff that that you don't want to deal with. Right? That's the thing that you are replacing. And we can get in here too deeply into the human aspect and the scientific aspect to say like, hey, I don't want to deal with people because I freaking hate them. You know, that is more from the philosophical debates. This is also interesting to have now this kind of conversations and forums and describe this in a way that is public, so we can have this public conversations, which is very, very important to move on as a society or to move on as an individuals. But in any case, here it is important to recognize that, right? So we are writing the system is to give us the ability to actually is automate stuff. So things that we don't want to deal with that, and this is not only in software, but also in our life. So, for example, in my case, I just want to eat. I just want to eat cheap. I just when I want to eat, I want things cheap, delicious, nutritious. Cheap, delicious, and nutritious, right? Cheap, delicious, and nutritious. Cheap, CDN. I didn't come up with that, you know. It's like CDN, and for that I don't mean it's the content delivery network and all that kind of stuff. No, it's like CDN, bro. CDN, cheap, delicious, and nutritious, right? Now, with that, what I want to do is to, figuring out what are the things that will give me that stuff, create now a system for that goal, all right? And anytime I want to now update it, I can do that, but I can just simply is modify that particular components in the systems, right? Which is something that I did. I just only ate one time per day, all right? And of course, I follow the CDN, cheap, delicious, and nutrition. So I now have my chicken breasts. I have my 30 grams of chicken breasts. Followed by salt and pepper. So I put that on the oven, 150 degrees, for about 20 minutes. And then in the meantime, I make my own pancake made of flax seeds. So grind flax seeds or flax flour, 100 grams of flax. We have 100 grams of flax flour with 3 eggs, a little bit of salt, I batter that. Batter. Um, mm, mm, mm. I mix that. Exactly. So I mix that. Exactly. So I mix that. I don't use any batter for that, or battering. It's like I just mix that. Then I before that on this on a on a standstill on a pan, yeah. So on a pan, now I put some 10 grams of 10 grams of all right, the 10 grams of butter, but I think is yeah, but butter. Yep. And I love the image here. They put right. Um, I put that, it's like I put that 10 grams of butter here over this pan. Of course, I turn out the oven, so I leave that warm a little bit, and then I put now the batter on top of that. Uh, so I put something on top of this. So I put a plate or something that to cover up, right? And also I put another. I put an oven. I put a. I put a pot. Okay. I put a boiling pot. I put a put a. I put. What I Yeah, I made a boiling. Uh, I made a. I made a. I put a bowl. I put a bowl. I put a bowl. I put a pot on. I put a pot in boiling water, so I can. So I put a pot. I put a bowl. I put a pot. Exactly. I put a pot on an oven with boiling water. I add the carrots to actually just release a little bit of beta carotene, and also the so after 10 minutes roughly, I put down the cabbage, so purple cabbage and green cabbage. And after 10 minutes, well, less than, after 5 minutes, I put that, and after 10 minutes, I put out, I drain the water, I drain all of this boiling water in a basket. So I now chuck a little bit of the water that I have, the carrots and cabbage and all that kind of stuff. And then now I hash that to put it on a bowl and and grate. Great. And grate. Okay. And then I put it in a bowl and add some green cheese. Add some green cheese. Add some Parmesan green cheese. and then I grate some Parmesan cheese on it. Exactly. Okay, so I grate some Parmesan cheese on it, right? That's great. That's interesting. Now, then, and again, I might be quite boring for all of that, but this is part of the learning process, and this is the reason why I'm actually putting all of this time and effort to record myself in this. So that's part of the job. So, in any case, the entire reason of describing all of the things that I need to do or that I do to give me now is what I need, okay? Which is in my case is CDN, bro. CDN. It's like cheap, delicious, and nutritious, right? Now, this is a system that I made, and this is the time that it take me to actually achieve this goal, the destination. So this is pretty much exactly when we are now developing is our applications like this. And I find out the power of, I'm not saying anything new, but I find out the power of doing things in a very systematic way for a goal is something that is powerful. This compound interest is massive, man. Massive, 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 massive. So, in any case, after we went through also describing this CI/CD process, why we use GitHub Actions instead of Jenkins, because now it is allow us to define all of these workflows that give us now the ability to run is this CI and CD process, continuous integration, continuous delivery, all of this check. Anytime you say, hey, it's gonna build and test, and if everything went well, with those new changes added to the code base, all right, generate an artifact. And that will be moved to now in a staging environment, which is close to production data, to run some of the tests, and if that went well, all right, then it's not to deploy that. So it's going to do that. And that's not the end, because we need to operate on that and then monitoring. And if everything went wrong or if we need to add some new features, all right, it's time to do that again. So plan, code, and then integrate to your CI/CD process, and so on and so forth, right? With GitHub, it's very straightforward. We use now workflows to do that. That's a great thing. That's a very powerful stuff here. So GitHub now provide you is a virtual machines where you can define all of your workflows that'll be triggered based on a series of events. It can be GitHub events or schedule that you can add to, or also the webhook you want to trigger to. So let's say, hey, I want to now send an HTTP post to a REST API, okay? And regardless of each one of those events, I want you to now run this series of jobs. Okay, so when each one of those events happen, run these jobs that is made of bash scripts, steps, or GitHub custom actions, which is recurring, tedious, and complex tasks to do. So for example, cloning a repo inside of this virtual machine, or set up the correct build tool change for your build environment, or set up the authentication workflow, or set up the authentications for third-party vendors, right? Or you want to define is now is catching, which means that anytime we're running or anytime we build and test our code, we want is to somehow is catch some of these folders here. And those folders or some We want is to avoid ourselves to repeat. We want to save ourselves time anytime we need to run this. Anytime we need to install the dependencies and build the code and then run the test, right? So that's what we have now catching there. And also, this is entering the realm of IT security and compliance, because it is very important for us to understand that when we are now, whoever is the owner of that repo, it has a huge responsibility, and you don't want, as a company, as a CEO of the company, actually put all of that responsibility on one single person or on a team, right? So that's why we have now these IT security models and the compliance that we need to follow. So for example, in the IT security, we have Castle and Moat, and now we have is the Zero Trust security policy model, and how when now companies, for example, Gartner, which is this multinational North American IT consulting firms, where each one of their clients say, hey, we want now security as a top priority. We want built-in security in our system, not a layer, then come out with this solution of the Zero Trust policy model. One of the analysts, or a couple of analysts in that company. So that's interesting because now this is also a way to create is applications in this distributed environment. So that's what we have, for example, this is a SASE model as a way to now combine its network security and network connectivity. Again, this is the role of this is an intersection between the IT, the software development, as well as security and finance and compliance, you know. But again, the TLDR of this is understand that that particular model exists, the SASE, which is the secure access server's edge, all right, which is a great theme, all right. And it follows several principles of that. So one of them is secure web gateway. The other is zero trust policy models. The other is CASB. Is that, hey, clouds, this, I'm going to provide now a series of security service, pretty much like physical security firms, where they provide you is now surveillance, foot patrols, verification. But now in the context of the digital world, I'm going to provide you now this series of services, which is made of the CASB. It's encompassed in this acronym, the CASB, Cloud Access Security Broker, where the principle stands for is, hey, data threats, compliance, data threats, threat security, data protection, compliance, and observability. And also we have another principle for on the SASE model, which is, hey, let's go into also is now run this software per network, allow a software to run per network, or one as a service, which is like another interesting stuff, and these next generations as well. In any case, so all of this is just to understand that, especially if you're handling a repo, a corporate repo, there is some sort of security and compliance to follow. Okay. And then we went through actually is how we can run our CI/CD process in a way that saves us time. For example, for catching dependency and the subtle and the difference between catching dependency and artifacts. And then now the next topic on the testing, which is component testing. How we went through that and described briefly is this component testing, and what is the end, what is the value proposition of all of this is to give us confidence on the UI development without having to spin up a full browser, without having to get a full browser driven integration, because this is something that is quite resource consuming, and we want to make sure that our UI components work as expected. So this is also as a way to actually for the QA team to say, hey, you know what, this will work as expected for those user stories and all that kind of stuff, right? So this is great because with this component testing, we as a UI specialist, we need to face some of this particular challenge. We use here is VTest and this component testing, because at the end of the day, unlike unit testing where we test is in JavaScript, now we want us to test is user components, which is HTML, CSS, and JavaScript, all right? So we use now a runner to do that, and that is HappyZone or GSDOM, where this runner, which now is implemented on Node, to behave like the DOM without spinning up the entire UI visualization. So locally for us, we have now VTest that it wants to integrate now is the build and test process into one single pipeline, all right? So shout out to the creators of that, which is Evan Jew, Jesus, completely. And now how, by looking at this testing, I think that's quite interesting, very interesting, very interesting. So by defining by looking at how can we use VTest and how we can configure that in a way that it provides us is some of this test environment, not only the runner, the Node.js DOM, the DOM implementation, or this Node.js, or the DOM implementation of in Node, right? So for example, like HappyDOM or HappyDOM or GSDOM, but also is the language or the library that we need to run and check our components, which is Jest. So we combine that, we look at how can we now starting to run our tests, and how it is important to have now a wrapper for testing our components or UI elements for most complex and common things. Ensign was something that was developed before that. It was created by actually Airbnb as a way to make sure that this component work as expected, all right? And that now evolved to something called the testing library, right? So this testing library is now provide a nice little wrappers when you are going to test your UI elements, whether it's Angular or Vue or React or Preach or any other framework out there. So that now give us is this query methods, for our components, a very nice little conventional query methods. We can use a screen for that, which is a helper method that is gonna check and provide some of these query methods to run our UI component test, the screen. And also, how can we now is all right. With testing library that now exposes this query methods and also the screen and the events that we can fire from our UI components, it also exposed now is this user interactions objects that allow us is to, well, verify is the most common of those tests, right? So for example, it's like typing or for key up, among other stuff that you can go with, right? So not only this, looking at how you can define and using all these particularly tools, is also to understand what is the end goal and what are the problems that happens here. And one of them is because we are testing our components, and unlike function, which is pretty much the same, right? And this is one of the value proposition of function, functional programming, is to say, hey, let's going to now describe is the functions in a pure way. In other words, single input, single output, right? Without affecting anything outside of this. And that's when we, as similar for function in JavaScript and component, is that, hey, this is one of the things that functional programming propose you to, especially for running this. It's like, hey, make sure that this function, as much as you need, doesn't invoke any side effect, or doesn't just take one single input, one single output. That's all. Now, because sometimes our UI component needs to depend on some external stuff, usually a store, to actually, that store is going to keep track, is the one who's going to coordinate at which data is currently on, right? Is the coordinator. So similar to the yeah, that's right. Similar to our component development, it makes a lot of sense to actually deal with that. Now, how can we deal when our components actually depends on some external stuff? Well, in the context of React, you say, hey, let's go to wrap this component with everything that it needs to, with a provider, all right? Let's go to wrap now this component and this component is going to now wrap into a provider, which is something that we did here in our code. There you got it. Okay, for example, in our list component, let me actually go to what we really care about here, which is enterprise UI development. npm run def. I mean, it's npm start because we're using is create React for that. That's great. So for example, now here, right? So when you have a component, and this component, again, this is just an example. There are other examples with component. This is pretty much the thing that we do, especially in our UI, to show to render a list of elements, and so on and so forth. So we have now this one, okay? And because these components, now when you add an item here, you say, hey, new item here. You add a new item, say, well, the new item 1. You add a new item 1. And then you want to make sure that when you click to this, you're going to move to another section of that. Because this data, this state is not managed by the component itself. It's managed by this global state, this global store, okay? And because now you have this relationship between one component and the another, and this component is not a pure component, it's in fact something that is casting this side effect. So one way to do that is to abstract that logic, okay, and put it into one particular place, all right, or recreate that into a new state. So, what are the trade-offs of each one of them, right? What are the trade-offs of each one of them? So for example, here in our example, this is packaging list, like this, and our index, what we did is just that. So our packaging list actually doesn't depend on, but the item list, in fact, actually make use of that, right? So in the context, let me see if I can show this. No. All right. Enterprise UI development here. You got it. Okay. All right. So in the event of now having several subcomponents in React, okay, this is in React, having several components that needs to actually that depend on that state, all right. In our index, we say, hey, let's go to now wrap this component, all right, and it's inside of this component, this wrapper providers. We're going now to is then on our test actually import that, all right, or find a way to create that, find a way to create is now an abstraction for that, like this, all right, where you say, hey, I want you to now render this with this data that I'm creating here, with this store data. And because when you want to create out a store, when you want to actually simulate or create this new state of our data, this is when things starting to be quite interesting, because this is now actually getting into the weeds. The TLDR of this is that any time that a component is using an external state, that external state must have the ability to create a new instance for that. So we can replicate everything here in a new state. So that's just to briefly describe how do we get here, okay? And because of that, we need to also explore some other architectural patterns. So let me actually here move to this here, and some architectural patterns to say, hey, that's great, that's good, that's for testing, but what about when we need to not only test is just one component? We're talking about scalability. Well, what happens when we need to test is now multiple components, right? What is the architecture that we can use to actually make that much more easy to go with, to test that? So that's now entering to the realm of the architecture, these recurring patterns that you're going to see. And usually using the hexagon architecture, where now everything in there is split into adapters and ports. Give me a second. So if we read about this, the hexagonal architecture, right? So the pattern, port, and adapter, object structural. From his blog, by the way. Japanese translation, Spanish translation, original explanation, wiki. Oh, oh, okay. Oh, this is an image, exactly. Okay. This has been continually active since 1996. With apologies, it's now under construction. Damn, son. Oh my god, that's hilarious. jQuery or WordPress, exactly. jQuery, WordPress, and none of that. WooCommerce, contact form 7, that's right. Anyway, but that's it. Hmm. Mm-hmm. Mm-hmm. Mm. Mm-hmm. Mm-hmm. Okay. 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 I think this is something that we can start to read here, right? Did the hexagonal onion clean and CQRS? How I put it all together. So this board is part of the Software Architecture Chronicles, a series of posts about software architecture. And then I write about what I have learned about software architecture. Again, and at the end of the day, we have now this software architecture is just to make the end goal of this is to make the code maintainable, which is the ability to add, remove, or change and update and migrate without the fear of breaking something, or reduce that as much as possible. So that's the whole goal of this. Now, in then, I write about what I have learned about software architecture, how I think of it, and how I use that knowledge. The content of this post might make more sense if you read the previous post in this series. After graduating from university, I followed a career as a high school teacher until a few years ago I decided to drop it and become a full-time software developer. From then on, I have always felt like I need to recover the lost time and learn as much as possible, as fast as possible. So I have become a bit of an addict in experimenting, reading, and writing, with a special focus on software designing and architecture. That's why I write this post to help me learn. In my last post, I have been writing about many of the concepts and principles that I have learned a bit about how I reason about them. But I see this as just a piece of the big puzzle. Today, in the last post, the Software Article Chronicles here. The importance of knowing our history. Those who fail to learn history are doomed to repeat it. Who is George Santana? Is a writer? Philosopher? Alright. Alright. The life of reason. That's one of the reasons why actually I try to understand how do we get here. Post of the Software Architecture Chronicles. The Software Architecture Chronicles, Software Architecture Premise, Programming Languages, Architectural Style and Architectural Pattern versus Architectural Style versus Pattern versus Design Pattern, Monolithic Architecture, Layer Architecture, MVC and its alternative, Model View Controller, okay, Hierarchical Model View Controller, Model View Presenters, Model 1, Model 2, Model View View Model, Model View Presenter View Model, Resource Method Representation, and Actions Domain Responder. Okay. Holy moly, bro. EBI architecture, packaging and naming, domain-driven designs, port and adapter architecture, onion architecture, clean architecture, event-driven architecture, from QCS to CQRS, service-oriented architecture, explicit architecture, XDD, hexagon, onion, clean, cure, how I put it all together, explicit architecture, 02 for more than concentric layers, explicit architecture 3, reflecting architecture and domain code. And then you got all of it. Explicit architecture 4, documenting the architecture, evolving a project from MVP to P, 4+1 architecture view models, and architecture quality attributes. Damn, son. Okay. Interesting. You might wonder, hey, this might be quite boring. But this is a very important, this is a stepping stone through that. This is a stepping stone to move through that. Oh my God. Yeah, it is. Oh my God. Yeah, it is, man. Mm-hmm.
Hola Uriel, ¿cómo estás? Soy Marga. Escúchame una cosa. Me llamaron del consorcio que hay un problema de caños en la cocina del piso 12B. Vos sos el 12C. Pero parece que también tiene que ver con algo de la cocina de tu lado. O sea que hay que, entre las dos cocinas hay un problema de caños. Se está yendo para los techos hasta del 10B. Es urgente. Por favor, decile a Ismael qué días y a qué hora estás vos para que ellos puedan entrar a arreglar el problema, ¿sí? Y que Ismael le avise al consorcio. Si no, decime a mí a qué hora pueden entrar al departamento y yo ya les aviso a la administración. Besos. Y gracias, ¿eh?
Hola señora Margarita, buenos días, ¿cómo está? Perfecto. Bueno, les digo entonces, hablo directo. Hola, buenos días señora Margarita, ¿cómo está? Perfecto. Bueno, hablo directamente entonces con Ismael para que me digan qué día tienen pensado hacer la reparación y bueno, y coordinarme también con la fecha para ver si puedo estar acá como tal. Y pido un permiso en el trabajo como tal, a ver si puedo quedarme aquí también como inspeccionando el trabajo. Y bueno, y lo voy notificando de los avances que vayan haciendo también.
Hola hermano, ¿cómo estás? Buen día. Bueno, ahí cambié tu programa. Vamos a implementar unas cositas nuevas en especial el día 4. Ese día sería fantástico que pudiéramos hacerlo juntos. Que me gustaría ver cómo lo hacen, así que podamos coordinar qué día de tu semana cae el día 4 y dónde nos vemos. Pero bueno, empieza a echarle bola, a ver si las piedras y mucho éxito, Roncillo.
Perfecto, Rey. Dale, ¿cuánto sería entonces? El día 4 podría ser... eh, perfecto, perfecto, Rey. Bueno, dime cuánto entonces es la transferencia y te comento entonces qué día nos podemos ver el día 4 como tal. All right. This is quite important, especially as we move on into the UI development. As it is. Okay. I will talk about most of this subject in time series of posts. Non-structured programming, 1951 with assembly. Then you have now structured programming, layer 1 tier, with the UI, business logic, and data storage with Algo. Then you have now procedural and functional programming, which is now 1970 with Pascal, 1972 with C, and 1979 with Model View Controller. And then it come up that it's like, yeah, all right, it makes sense to structure all of this in functions, but at some point we need to handle this states. We need to have a way to handle this state. So that's why now, for example, the object-oriented programming says like, hey, let's going to bundle is now data and it is functionality together. So the first thought were in the late 1960s, and then you have now layering 2 tier. The first tier is with the UI, and the second tier with the business logic and data storage. Business logic and data storage, right? Is the functionality and the data. 1980s is with C++, CORBA, Common Object Request Broker Architecture. So the first stable version was only out in 1991. The first uses were during the 1980s. Then Erlang came in here. That's interesting. Erlang, which is a very niche programming language to manage concurrency. That's quite interesting. That's quite interesting. You also have other language like Clojure. All right. Exactly. Now the handling is, so they're using is Clojure for handling is concurrency in the language, and all of this has been inherited for us per pack, LSP, and then the layer 3. The first tier with the UI, which is this, the layer in tier 1 with UI, business logic, and data storage. Okay. The first tier with the UI, the second tier with business logic, and the UI representation logic in case of a browser as a client, and the third tier with the data storage. And this is when come out this message bus, Python, entity boundary interactors, Ruby, Delphi, Java, JavaScript, PHP, Model View Presenter, OCP, ISP, DIP, Solid, SDP, SAP, aspect-oriented programming, web services, ESB, Enterprise Service Bus. Although the bug that coined the term was published in 2004, the concept was already used before. And then on the 2000, which is ERSP, the solid, single responsibility. The OID, the open to extension, closed to modifications, the inversion control, and the dependency injection, the interface segregation, and the dependency injection. And then it now comes here with a single responsibility here. The solid. Single responsibility, open and closed principle, the LISOC substitution, the derivative class must be substitutable from their base class. The interface segregation principle, make fine-grained interface that are client-specific, and the dependency inversion principle is that depend on abstractions, not on concretion. Even though they point to that, That's quite interesting. All right. Oh my God. And then you got in the 2000 is the domain-driven design, model view model, port and adapter architecture by Alistair Cockburn. Then you have now CORIS and yes, common query responsibility segregation and event sourcing, onion architecture, and microservice at Netflix. The onion architecture the onion architecture 10 years
Ever
ago.
did talk about this was in 2006 at QCon San Francisco. And actually, some of the slides are still the same from all the way back then. I have probably done this or a similar talk 50 times over the last couple years. When I did the first talk, it was awful. So I come in, and I've never really talked at conferences or anything like that before. And I'm talking about domain-driven design and messaging systems and these new patterns. And I come in, and my front row is Martin Fowler, Eric Evans, and Gregor Hoppe. I'd never met any of them before. I think I went through my entire 60-minute talk in something like 17 seconds. We will not do that today. Now, when we first started looking at things like event sourcing and where the ideas came from, and they're not new ideas. In looking for the book and trying to do history about event sourcing,
That's very, very interesting, man. We need to actually deal with this early. It's because all of these persons, all of these people actually, people before you, they say, hey, you know what? It is very hard to handle the concurrency because now our applications now not only are monolithic, they're not only run here in this computer, but also it needs to depend on other computers, right? Distributed computing. Hey, you do this and then you do that. So you're handling this transaction in these servers, and then you add the user registration and so on and so forth. So that's when starting to boom with this. And then you have now the clean architecture, data context interaction architecture, and C4 model. That is huge, man. That is huge, man. Interesting. Very, very interesting. So programming paradigms is a relatively high-level way to conceptualize the structure the implementation of a computer program. A programming language can be classified and supported on one of more paradigms. So you have imperative, code directly controlled execution flow, and a state change, explicit state change that changes a program state. All right. So you have procedural, object-oriented programming. You have now the declarative, code declare property of the desired results, but not how to compute it. Describe what computation should perform without specifying detailed state change, functional logic, and reactive. That's what it is. So this is now patterns of this. And the other is the concurrent programming. Has language construct for concurrency. For example, promises is one of them. Another is generators, right? Another is observables. But has language construct for concurrency. This may involve multi-threading, supporting for distributed computing, message passaging. For example, in the case of generators, shared research, including shared memory, or futures, aka promises. Actor programming, concurrent computation with actors that make local decisions in response to environment. And then you have now constrained programming, data flow programming, force recalculation of formula where data values change. Distributed programming has support of multiple autonomous computers for that. Genetic programming, meta programming, template programming, reflective programming, pipeline programming, rules-based programming, and visual programming. That is huge and interesting as well. That is huge and interesting. Why is this? Because here we're getting into the realm of truly understand what are we doing, especially when we're writing on applications, and what are all of these different patterns that we combine them. Why is this? Because this is very, very important, especially as you're going to talk to the computer, because now computers or programming is now the art of the science. How can we now communicate with other human beings? That's what it is all about. It's like, hey, how can we now communicate to another human being this set of instruction that, well, it turns out that runs some instructions in a machine. So it moves electrons on the motherboard. Hey, is this will be imperative or it will be declarative? All right, functional logic or reactive, or this will be is concurrent programming. All right, so if the language already provides some construct for that, or is the way data flowing, right? Meta programming, very, very interesting. Okay, all right. But here, as a way to explore now is this. Yeah, as a way to explore now this. Software architecture premises. No silver bullets. Exactly. And the terminology here. Some architectural styles are often portrayed as silver bullet solution for all forms of software. And this is something interesting because it comes from our natural sense of saying, hey, we need to find a way to have certainty. Sorry. But certainty does not exist. It's not a guarantee, man. But certainty is not a guarantee, as will happen. Terminology, functional. The only certainty is change. Terminology. In the software development world, there is a plenty of ambiguity in the terminology used and such. Before continuing, it is important to clarify that the meaning I want to give to few terms I use. Functional. It is a piece of code, method, class, group, or classes that has purely technical role in the application. It is not related to the domain. It simply represents a technical capability in the applications. Layers, factories, value object, view model is a technical representation. Conceptual. Okay. It is any piece of code, method, class, group of classes that reflects a domain concept in the application. It is directly related to the domain and it represents a business capability. Okay, so some terminology here. Functional, that representing is the technical capabilities. And the conceptual, that represents the business capability. This separation doesn't mean that a code unit cannot be referred in both ways, functional and conceptual. For example, a money class can represent a business, a domain concept, and be defined as a value object. Exactly, can represent and design here. If I refer to it as a concept, I mean the domain money concept, but if I'm referring to the functional aspect of the class, then I mean the technical characteristic of a value object. Number of ID may be immutable, etc. But it says to describe one of the representation and the other is the design. What it represents and how I design, how I draw this. So package, any set of group together ideally follows some of the set of rules. Modules, I use a definition given in the software architecture in practice, which says that a module is a functional package. It reflects a technical capability in the application. It is decoupled and can be swapped by another implementation. For me, model exists at a low granularity level. For example, a security model or the ORM, but also at a higher level granularity like the client and server. Blocks of applications model provides for functional cohesion. Components. But again, it's any functional package and it reflects a technical capability. Hey, what this thing can do, and it can be fine-grained or higher. Then you have another component. Also use the definition given in the software architecture in practice, where the author, software architecture in practice, is this book. Is from this book, Software Architecture in Practice, where the author defined a component as a conceptual package reflecting a business capabilities. Okay, define a component as a conceptual package reflecting business capability. A model reflects technical capability and a component business capability. Interesting. It is also ideally decoupled from other components and models. Example can be user, product, or checkout, but it is business capability. The most important thing to remember though is that ideally it reflects a bound context. Component provide for conceptual cohesion. Conceptual cohesion is referring to the business, all right? Related and represent to the business. And functional cohesion is represent to the technical capabilities or the design here. Interesting. Okay. Oh my God. This is quite interesting. This is quite interesting here because now ideas is now clarified. So we get clarity here. All right. Then you get now an application. I see an application as a user-facing code. The UI, which is built on top of the components. For example, we can have a set of components on top of which we build a web shop. This web shop, however, has a UI which is used by the consumers browsing and buying products. Storefront. And it has another independent UI which is used by the shop administrators to manage products, stocks, payment provider, etc. Those are two independent applications. But an application, I see an application as a user-facing code. And that makes a lot of sense. Okay, user-facing code. Quite interesting. User-facing code. User-facing code. User-facing code. User-facing code. In Amsterdam. Interesting. Okay. But again, this is what it is. Anyway. But I think. Okay. Okay. This is a very interesting, at least for him, right? To describe this and to have more clarity when we define concepts like that, like functional and conceptual, and then down the line you can decide what it is or refine them. So a package is any set of classes grouped together, ideally following some set of rules. And the model is just a functional package. It reflects the technical capability of this. And the component is a conceptual package reflecting the business capabilities. And the application is the user-facing code. The UI which is built on top of the component. For example, we can have a set of components on top of which we build web shop. This is the application. And these web shops, however, has a UI is used by consumers browsing and buying products, storefront. And it has another independent UI which is used by the shop administrator. And then you have the system. I think of system as a set of applications, what is in the context of computer science or software development, that somehow work together to provide functionality to a wide range of enterprise necessities, forming an enterprise-wide system, an enterprise application. Okay, a set of applications, user-facing interface, all right, that somehow works together to provide functionality to a wide range of enterprise necessities, forming an enterprise-wide system, an enterprise application. This application may or may not be built on top of the same components on this conceptual package, reflecting business logic or business capability. In the previous example of a web shop, the system is the web shop as a whole. Exactly. In the previous example of the web shop, the system is the web shop as a whole with all of the different UI, including the two applications built on top and on the same business components, the storefront and the admin, but also include other third-party applications like payment providers and shipping providers. And architecture. There are many simple definitions of software architecture, and I think it is good to have them, but I think it is easy to understand what it is. And even more important, defining the deliverables of the architecture. What it should deliver to the project. There are many simple definitions of software architecture, and I think it is good to have them, but I think it is easy to understand what it is. And even more important, defining the deliverables of the architecture and what it should deliver to the project. Software architecture is a set of structures needed to reason about the systems, which comprise software elements, relations among them, and property of both. Wait, what? Come on, man. This is how I reason about architecture. All technical decisions that are cross-cutting to all feature development, ES frameworks, coding standard, documentation process, It is a set of technical decisions that are difficult to change later. Okay. All technical decisions that are cross-cutting to all feature development. It has frameworks, coding standards. Documentation, processes. It is a set of technical decisions that are difficult to change later in the project. It is the big picture view of the system, that broad strokes, the structure, the component, and their relationship. It prepares the project for change, often simply by delaying decision to the last acceptable moment. It prepares the project for reuse of components and models. For reuse of components, this business logic, this conceptual package represent business logic and technical challenge, or in technical capabilities. It is established standards for consistency of result and lightweight of process, like coding standard, the developing stage, continuous delivery and deployment. Exactly. It established standards for consistency of result, and lightweight of process. Coding standards like ES6 and like ESLint, the developing stage like Agile, continuous delivery and deployment, CI/CD. It is not responsible for only one person, but of a guild of experienced developers that belong to different features teams in a project. If you're not familiar with the concept of guild, take a look at the Spotify engineering culture here. Oh, they made that? Okay.
One of the big success factors here at Spotify is our agile engineering culture. Culture tends to be invisible. We don't notice it because it's there all the time, kind of like the air we breathe. But if everyone understands the culture, we're more likely to be able to keep it and even strengthen it as we grow. So that's the purpose of this video. When our first music player was launched in 2008, we were pretty much a Scrum company. Scrum is a well-established agile development approach, and it gave us a nice team-based culture. However, a few years later, we had grown into a bunch of teams and found that some of the standard Scrum practices were actually getting in the way. So we decided to make all this optional. Rules are a good start, but then break them when needed. We decided that agile matters
Rules are a good start, but then break it then when needed.
more than Scrum, and agile principles matter more than any specific practices. So we renamed
So principles are more great.
the Scrum Master role to Agile Coach because we wanted servant leaders more than process masters. We also start, but then break them when needed. We decided that Agile matters more than Scrum, and Agile principles matter more than any specific practices. So we renamed the Scrum Master role to Agile Coach because we wanted servant leaders more than process masters. We also started
Agile leaders rather than the Scrum Masters.
using the term squad instead of Scrum team, and our key driving force became autonomy. So what is an autonomous squad? A squad is a small, cross-functional, self-organizing team, usually less than 8 people. They sit together and they have end-to-end responsibility for the stuff they build. Design, commit, deploy, maintenance, operations, the whole thing. Each squad has
Design
operations for the stuff they build. Design, commit, deploy, maintenance,
design, commit, deploy, maintain,
operations, the whole thing. Each squad has a long-term mission, such as make Spotify the best place to discover music, or internal stuff like infrastructure for A/B testing. Autonomy basically means that the squad decides what to build, how to build it, and how to work together while doing it. There are, of course, some boundaries to this, such as the squad mission, the overall product strategy for whatever area they are working on, and short-term goals that are renegotiated every quarter. Our office is optimized for collaboration. Here's a typical squad area. The squad members work closely together here with adjustable desks and easy access to each other's screens. They gather over here in the lounge for things like planning sessions and retrospectives. And back there is a huddle room for smaller meetings or just to get some quiet time. Almost all walls are whiteboards. So why is autonomy so important? Well, because it's motivating, and motivated people build better stuff. Also, autonomy makes us fast by letting decisions happen locally in the squad instead of via a bunch of managers and committees and stuff. It helps us minimize handoffs and waiting so we can scale without getting bogged down with dependencies and coordination. Although each squad has its own mission locally in the squad instead of via a bunch of managers and committees and stuff. Autonomy is so important. Well, because it's motivating, and motivated people build better stuff. Also, autonomy makes us fast by letting decisions happen locally in the squad instead of via a bunch of managers and committees and stuff. It helps us minimize handoffs and waiting so we can scale without getting bogged down with dependencies and coordination. Although each squad has its own mission, they need to be aligned with product strategy, company priorities, and other squads. Basically, be a good citizen in the Spotify ecosystem. Spotify's overall mission is more important than any individual squad. So the key principle is really be autonomous, but don't sub-optimize. It's kind of like a jazz band. Although each musician is autonomous and plays his own instrument, they listen to each other and focus on the whole song together. That's how great music is created. So our goal is loosely coupled but tightly aligned squads.
Loosely coupled but tightly aligned because it's about values, bro. It is interesting because at the end of the day, capitalism has found a way to motivate or understand the need for us for coordination. This kind of stuff is based on money, because all of this, if you don't pay a ton of money to this kind of people, there is no incentive to actually pursue this kind of stuff. So now capitalism, like it or not, what have show us is to say, hey, coordination is important. Coordination is what now drive us to produce, to increase production, and also have margins.
We're not all there yet, but we experiment a lot with different ways of getting closer. In fact, that applies to most things in this video. This culture description is really a mix of what we are today and what we are trying to become in the future. Alignment and autonomy may seem like different ends of a scale, as in more autonomy equals less alignment. However, we think of it more like two different dimensions. Down here is low alignment and low autonomy, a micromanagement culture. No high-level purpose, just shut up and follow orders. Up here is high alignment, but still low autonomy. So leaders are good at communicating what problem needs to be solved, but they're also telling people how to solve it. High alignment and high autonomy means leaders focus on what problem to solve, but let the teams figure out how to solve it. What about down here then? Low alignment and high autonomy means teams do whatever they want and basically all run in different directions. Leaders are helpless and our product becomes a Frankenstein.
Which is what happened with all of this, is that you have high autonomy but low alignment. And this is quite interesting because this is what happened with a lot of these big companies. Like, hey, they have high autonomy but low alignment. So that's the reason why they try to enforce this part, kind of this stuff.
Trying hard to be up here, aligned autonomy. And we keep experimenting with different ways of doing that. So alignment enables autonomy. The stronger alignment we have, the more autonomy we can afford to grant.
And by alignment, we talk about is values here.
That means the leader's job is to communicate what problem needs to be solved and why, and the squads collaborate with each other to find the best solution. One consequence of autonomy is that we have very little standardization. When people ask things like, which code editor do you use, or how do you plan? The answer is mostly, depends on which squad. Some do Scrum. The answer is mostly, depends on which squad. Very little standardization. When people ask things like, which code editor do you use, or how do you plan? The answer is mostly, depends on which squad. Some do Scrum sprints, others do Kanban. Some estimate stories and measure velocity, others don't. It's really up to each squad. Instead of formal standards, we have a strong culture of cross-pollination. When enough squads use a specific practice or tool, such as Git, that becomes the path of least resistance, and other squads tend to pick the same tool. Squads start supporting that tool and helping each other, and it becomes like a de facto standard. This informal approach gives us a healthy balance between consistency and flexibility. Our architecture is based on over 100 separate systems coded and deployed independently. There's plenty of interaction, but each system focuses on one specific need, such as playlist management, search, or monitoring. We try to keep them small and decoupled with clear interfaces and protocols. Technically, each system is owned by one squad. In fact, most squads own several. But we have an internal open source model, and our culture is more about sharing than owning. Suppose Squad 1 here needs something done in System B, and Squad 2 knows that code best. They'll typically ask Squad 2 to do it. However, if Squad 2 doesn't have time, or they have other priorities, then Squad 1 doesn't necessarily need to wait. We hate waiting. Instead, they're welcome to go ahead and edit the code themselves, and then ask Squad 2 to review the changes. So anyone can edit any code, but we have a culture of peer code review. This improves quality and, more importantly, spreads knowledge. Over time, we've evolved design guidelines, code standards, and other things to reduce engineering friction, but only when badly needed. So on a scale from authoritative to liberal, we're definitely more on the liberal side. Now, none of this would work if it wasn't for the people. We have a really strong culture of mutual respect. I keep hearing comments like, "My colleagues are awesome." People often give credit to each other for great work and seldom take credit for themselves. Considering how much talent we have here, there is surprisingly little ego. One big aha for new hires is that autonomy is kind of scary at first. You and your squad mates are expected to find your own solution. No one will tell you what to do. But it turns out, if you ask for help, you get lots of it, and fast. There's genuine respect for the fact that we're all in this boat together and need to help each other. Now that may seem like a pretty high satisfaction rate, especially considering our growth pain. From 2006 to 2013, we've doubled every year and now have over 1,200 people. But then he continues. This is of course not satisfactory, and we want to fix it. If you're one of those unhappy 4%, please contact us. We're here for your sake and nothing else. So good enough isn't good enough. Half a year later, things had improved, and satisfaction rate was up to 94%. This strong focus on motivation has helped us build up a pretty good reputation as a workplace. But we still have plenty of problems to deal with. So yeah, we need to keep improving. Okay, so we have over 50 squads spread across 4 cities. Some kind of structure is needed. Currently, squads are grouped into tribes. A tribe is a lightweight matrix. Each person is a member of a squad as well as a chapter. The squad is the primary dimension, focusing on product delivery and quality, while the chapter is a competency area, such as quality assistance, agile coaching, or web development. As squad member, my chapter lead is my formal line manager, a servant leader focusing on coaching and mentoring me as engineer, so I can switch squads without getting a new manager. It's a pretty picture, huh? Except that and mentoring me as engineer, so I can switch squads without getting a new manager. It's a pretty picture, huh? Except that it's not really true. In reality, the lines aren't nice and straight, and things keep changing. Here's a real-life example from one moment in time for one tribe. And of course, it's all different by now. And that's okay. The most valuable communication happens in informal and unpredictable ways. To support this, we also have guilds. A guild is a lightweight community of interest, where people across the whole company gather and share knowledge within a specific area. For example, leadership, web development, or continuous delivery. Anyone can join or leave a guild at any time. Guilds typically have a mailing list, biannual unconferences, and other informal communication methods. Most organizational charts are an illusion, so our main focus is community rather than hierarchical structures. We've found that a strong enough community can get away with an informal, volatile structure. If you always need to know exactly who is making decisions, you're in the wrong place. One thing that matters a lot for autonomy is how easily can we get our stuff into production. If releasing is hard, we'll be tempted to release seldom to avoid the pain. That means each release is bigger and therefore even harder. It's a vicious cycle. But if releasing is easy, we can release often. That means each release is smaller and therefore easier. To stay in this loop and avoid that one, we encourage small, frequent releases and invest heavily in test automation and continuous delivery infrastructure. Release should be routine, not drama. Sometimes we make big investments to make releasing easier. For example, the original Spotify desktop client was a single monolithic application. In the early days, with just a handful of developers, that was fine. But as we grew, this became a huge problem. Dozens of squads had to synchronize with each other for each release, and it could take months to get a stable version. Instead of creating lots of process and rules and stuff to manage this, we changed the architecture to enable decoupled releases. Using Chromium Embedded Framework, the client is now basically a web browser in disguise. Each section is like a frame on a website, and squads can release their own stuff directly. As part of this architectural change, we started seeing each client platform as a client app, and evolved 3 different flavors of squads: client app squads, feature squads, and infrastructure squads. A feature squad focuses on one feature area, such as search. This squad will build, ship, and maintain search-related features on all platforms. A client app squad focuses on making release easy on one specific client platform, such as desktop, iOS, or Android. Infrastructure squads focus on making other squads more effective. They provide tools and routines for things like continuous delivery, A/B testing, monitoring, and operations. Regardless of the current structure, we always strive for a self-service model. Kind of like a buffet. The restaurant staff don't serve you directly. They enable you to serve yourself. So we avoid handoffs like the plague. For example, an operations squad or client app squad does not put code into production for people. Instead, their job is to make it easy for feature squads to put their own code into production. Despite the self-service model, we sometimes need a bit of sync between squads when doing releases. We manage this using release trains and feature toggles. Each client app has a release train that departs on a regular schedule, typically every week or every 3 weeks, depending on which client. Just like in the physical world, if trains depart frequently and reliably, you don't need much upfront planning. Just show up and take the next train. Suppose these 3 squads are building stuff, and when the next release train arrives, features A, B, and C are done, while D is still in progress. The release train will include all 4 features, but the unfinished one is hidden using a feature toggle. It may sound weird to release unfinished features and hide them, but it's nice because it exposes integration problems early and minimizes the need for code branches. Unmerged code hides problems and is a form of technical debt. Feature
and it exposes technical debt.
Toggles let us dynamically show and hide stuff in test as well as production. In addition to hiding unfinished work,
We're just using it now.
we use this to A/B test and gradually roll out finished features. All in all, our release process is better than it used to be, but we still see plenty of improvement areas, so we'll keep experimenting.
And
This may
was in
seem like a scary
2019,
model,
man.
letting each squad put their own stuff into production without any form of centralized control. And we do screw up sometimes, but we've learned that trust is more important than control. Why would we hire someone who we don't trust? Agile at scale requires trust at scale, and that means no politics. It also means no fear. Fear doesn't just kill trust, it kills innovation, because if failure gets punished, people won't dare try new things. So let's talk about failure. Actually, no. Let's take a break. Get on your feet, get some coffee, let this stuff sink in.
AI Whisperer, chief scientist and co-founder of YAGME. Consulting at Scripps. Interesting. Scripps.se. Your transformation partner in generative AI, making the world more human. Previously Spotify, Lego, Minecraft, and playing Geth. Okay.
And company, 5-star chef, and having him chop onions. The more card transaction approved, former architecture, which by the way is the T in GPT, come out. But any kind of content, such as, and when she's heard enough, she starts seeing the of humans painstakingly testing and evaluating source. Others are commercial code, JSON, or HTML.
That's quite
I use this a
interesting.
lot myself to generally like transforming or combining images, unless I ask you for something. That way, it'll just listen and not isn't stuck in the basement after all. You can take him out for a walk. Initially, language models were just
Behavioral
word
control against
predictors,
available for
statistical
free
machines with limited
One of the
practical
most
use.
qualifying
But as they
compassionate
became
hunters.
large,
Okay, that was quite interesting. I can really recommend Jagni.ai. They were instrumental in BigPath. Join to our webinars. And then Crips.sa. Oh, I get it. I know. Okay. Okay, that is not even English. Okay. That's quite interesting. That's quite interesting. That's very, very interesting. That's very, very interesting here. Okay. Okay. All right. Okay. This is now talking about is. It's exploring now the culture here, and this is quite interesting. That is this.
Okay, quick recap from part 1. Our culture is based on agile principles. All engineering happens, something goes wrong, we follow up with a post-mortem. This is never about mantra, think it, build it, ship it, tweak it. The biggest risk is always building the wrong thing. So before building a new product or major feature, we try to define a narrative. Kind of like a press release or elevator pitch, showing off the benefits. For example, radio you can save, or follow your favorite artist. We also create prototypes to get us and build an MVP, minimum viable product. Just enough to fulfill the narrative, but far from feature complete. You might call it redeploying until they see the desired impact. Then they gradually roll out to the rest of the world, while taking. So with all this experimentation going on, how do we actually plan commitments, like for partner integrations or marketing events? And that sometimes involves standard agile planning techniques like velocity and burn-up charts. But if we have to promise a date, we generally defer that commitment until the feature is already proven. That's when people get to experiment and build whatever they want, no limits. If we try enough ideas, we're bound to strike gold from time to time. We talk about things like, what's the hypothesis? What did we learn? And what will we try?
Okay, this is quite interesting in terms of actually describing is this. Architecture, he's the guardian and promoter of the architecture, which is discussed as a guild. And he's one of the most experienced developers in the team department, which happens to have the extra responsibility of analyzing high-level problems and solutions. He's also benefit from a quality vote when making an architectural decision. It's important to note, though, that all developers end up being architecture, exactly, to some extent, as one of the reasons why I'm actually reading to this. And the architecture, they all contribute to the architecture in some way. And in the end, they all have the responsibility of maintaining the architecture in place. Ivory Tower architecture. The almighty Ivory Tower architecture is the anti-pattern of the architects, one of who takes upon him to decide over all issues related of the architecture. He castrates the other stakeholders' contribution to the architecture by not being open nor easily available to receive those contributions. Smell of a bad architecture and bad code. Rigidity, fragility, immobility, viscosity, needless repetition here, opacity, needless complexity here. So that'll be all for this video. Take care. Bye bye.